Okay, transformations, we've been doing them since chapter 1. So we're all good, right? Let's talk about our basic log graph. -1 base? No. Do you want to do base 2s? I think we did base 2s. No. Right, we're going to use that as our basic log graph. That's our basic log graph. Oh, actually, let's do it on this one because this is going to be helpful. Let's do a basic log graph with base 4. So log base 4x. Let's do a table of values. For log graphs, which one do we pick? Do we pick the x's or the y's? Pick the y. Yes. You got it. Because if I were to put this in exponential form, what would it look like? So this would be equal to some variable. So this would be base of 4, exponent of y equals x. Remember that it's the inverse to an exponential graph. That's why we put 7 and 8 together, is because it's the inverse to exponential. So if we pick -2, -1, 0, 1, 2, what are going to be our x values here? Maybe let's start at 0. When y is 0, what's x? 1. When it's 1, it's 4, 16. So going up, this would be 1/4 and 1/16. You guys good with that? Okay. So now we're talking about transformations. This is our basic log graph. So if we have these transformations, what does x minus 4 tell us to do? Where are we going? We're going to the right 4 units, and the -2 tells us 2 down. 2 units down, yes. So when we do this table, all we're going to do is look at our original table, and what are we going to do the x's? Mathematically speaking, we are going to add 4, and on the y's, we're going to -2. Okay, are you ready?
Yeah.
Okay. Okay, so let's start at an easy one. Let's go the nice whole numbers here. So x is I'm adding 4, so this is going to move to 5. And I'm going to go 2 down, so this would be -2. At 4, where am I going to be? I'm going to be at 8, and I was at 1, so I'm going to be at -1. 16, I'm going to be at 20, and where am I going to be? 0. So now I'm going up the chart. 1/4. I'm adding 4, so that's going to be 4 1/4 or 4.25, whatever close wrote. -1 -2. Thanks, David. Appreciate it. I felt a little lost there for a second. This is going to be 4 and 1/16, and this is going to be at -4. We all participate. Okay, so where did we say the asymptote was in this graph? What 0? It's vertical. So this happens at x equals 0. So now where is my new asymptote? That x equals 4. Because we moved over 4, so my vertical asymptote is going to change with anything that happens to the x's. All right, so if we were to do this, hey, don't forget to put your increments on there. Get out of my class, sir. How dare you say stuff like that? So I'm going to put my asymptote on. I like to do that. Would you lose marks if you don't know? But again, if you cross that asymptote, if your graph crosses at positive 4, you're going to lose the mark. So, does that make sense? Because this asymptote, that's okay. Quick nap, we're all good now? Okay. Okay. So let's go back for Canal. There's a lot of yes no. We're not getting through this one today. So if I were to graph this, this would be 4 and 1, 1 and 0. And now I start getting really close to that line. So this would be my basic logarithm graph with a base of 4. So that's my red line. Where's the asymptote on this graph? Where's the asymptote? No? No. Where is this approaching? Oh, you're looking at a horizontal asymptote? Remember with the logarithms, we have a vertical asymptote. Exponential graphs have horizontal logs. Think of L. A log graph? No. It's at 0. Look at these. What's happening to the x values? Where are they getting close to? Where are they getting close to? They're getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. Where are they headed to? 0. So my asymptote on that graph is going to be at x equals 0. Okay? So that means our asymptote will shift with anything that happens to the x. I don't care about the y anymore. The y only matters for exponential graphs. Now it's what's happening to the x. So we moved 4 units right. So what's going to happen to my asymptote? It's also going to move 4 units right. So now my asymptote is here. And these are going to be my values. So at 4 and 1/16, so that's really, really, really close to the line, I'm going to be at -4. At 4 1/4, I'm going to be at -3. At 5, I'm going to be at -2. At 8, I'm going to be at -1. Oh, that's just me. So f of x, this one's the log base 4, x minus 4 minus 2. The red one is my basic log base 4 graph. I find when I do these, when I do transformation, it really helps me to do my basic graph. No, not if you label it. Not if you label it. If you put it as a dotted line, you don't have to label it. But I can barely handle straight lines. Asymptotes have to be dashed lines because they don't exist. No, I was just doing it for fun. You don't have to put the equation together. Not for these. An implied asymptotic behavior is just as good as putting an asymptote on. But my worry is if you don't put the asymptote on, is that you'll accidentally cross the invisible asymptote that you didn't put on. No. If you put the dash line, any dash line you can put on there, it doesn't exist. So I don't mark it. You know what I'm saying? But it would be really easy for your arrow to cross over the 4, like at 4, x equals 4. So that's why I always put the boundary of the asymptote on. Because it keeps me in check of where my graph should actually go. But you don't have to. you can leave it, and as long as it has correct asymptotic behavior, I count it as if you had drawn that asymptote on. Does that make sense? All right, I got two people with their heads down. I got another crew having their own conversations. This we're going to go through really quickly. Easy stuff. Easy stuff. It's telling me state, oh, that's a bad word. State, what does state say? Give an answer with or without an explanation or justification. Okay, we can do that. Put it down, walk away. So what's happening? That's one. Where's the asymptote? That's a great question. Do you know, Canal? Yes, you do. If your asymptote's starting at 0 and you have a shift of 1 to the left, there you go. Okay, this is a trick. This is a trick question. And you guys fall for it every time. You gotta factor it. Me as well. Okay, so once you've factored it, now you can talk transformations. You cannot talk transformations here. You'd get half of it wrong. You totally could. I would be perfectly fine with that, but so far, Matthew, I'm kind of let down by that. So, again, I'm trying to give you guys strategies to help yourself. Don't talk about transformations if there is a 2 or a coefficient in front of that x. Don't talk transformations until you've actually factored it. So this would be horizontal stretch by a factor of how much? 1/2. And what else is happening? Where am I going? 5 units. Right. So if you had done it from here, you would have got this and you would have screwed up that. Happens. What about number 3? Yeah. Hey, Canal, where would my asymptote be on this one? No. There is no horizontal shift. Trick question. Oh, I totally threw you under the bus. Okay, this one. Okay, so we have a reflection. So that's the first thing. The second thing is we have a vertical stretch by a factor of, yeah. And the third thing, 2 units down. Oh. Okay, this is another trick question. It's true. It's not very tricky when I find out to you. Okay, so I'm just going to factor this for our mere mortals who can't see it. So this is going to be log base 3. And if I switch around, it's going to be negative x plus 1. Is there a bracket between the negative x, the negative and the x? No, so you got a common factor of that negative 1. So this is going to be log base 3, negative 1, x minus 1. Because again, you still would get your reflection correctly here, but you would have got your shift incorrect. So this is going to be a reflection where? Y-axis? And rate 1 unit. Okay, another trick question, but this time I'm not going to factor it. Let's see if we can do it without. Okay, so we've got a reflection in the y-axis. Hang on, I'm having trouble with my app there. Reflection y-axis, 4 units right. Where can all? Anyone else can know where the asymptote is? So here's my thing. Are you guys going to be able to do this? Will you remember this when I put it on the test?
No. Yes. Absolutely. Yeah.
Okay. The answer is absolutely. Okay, the last one here, I'm going to have a reflection. And I'm going to be 3 units. 3 units where? Right. Okay, we made it through page 1. Golden. Okay, you guys do this one. I'm going to hit pause. Now, where is my asymptote? You didn't figure it out. 2 units right with the reflection. So we're going to have a -1, x minus 2. So my asymptote is going to be at how about positive 2? Yeah, I knew you did. I was just ignoring you on purpose. Because you said it right the first time. So what side? So what side is normally our log graph go on the asymptote? Does it go on the right hand side or the left hand side? It usually goes on the right, right? But now we're doing a reflection in the y-axis. So you can anticipate if it was on the right, now it's going to be on the left. Okay, what are the points? Give me some coordinate pairs. Okay, well then let's go back. Guys, we've been together now for like 4 months. Some of us have been together longer. I think at this point you can take guesses, and we're all going to be okay with the top, right? On a daily basis, I screw up. I can't add properly. Do I stop teaching you guys? No. Sometimes. Sometimes we do. Right? That's our basic graph, right?
Yeah.
So if we're doing the table values for our transformation, okay, so if we're doing our transformations, am I doing anything to my y's? Nothing's happening to my y's. Okay, what's happening to my x's? I'm going to multiply them by -1 first, and then I'm going to add 2. So this is going to become -1/16, and then I'm adding 2 to it. So it's going to be 1 and 15/16. -1/4 plus 2 is going to be 1 and 3/4. -1 plus 2 is going to be 1. -4 plus 2 is going to be -2. -16 plus 2, -14. Oops, I said it. I didn't hear it. Sorry. What? I'm sorry. I screwed you over. I totally did. -2, I am at 1. And then I don't know what's next on there. I can do 1 3/4 and at -1. And this one, really, really close to the line. Cool. I imagine that goes through all those points. That makes sense, everybody? Easy peasy?
Yeah.
How did I get -10? -2, so it would have been a -4 plus 2 gives me the -2. So what we did here was we okay, so that's what we did mathematically, and we know from our transformation units, we do any multiplying before we do any adding. Right? All right. Do you guys think we could do this one?
Yeah.
Do you think we could do it quickly? It did. Maybe we should do it together. Let's skip it. Let's do this one. Woo. So, trick question? Trick question?
Yes.
Yes? So, we're going to have -2 log base 3, 3 bracket x plus 1. What's my basic log graph here? It's base 3 now. So all the other ones that we were working on don't really apply. Okay, you guys can do all these pretty quickly, right? Your basic graph, your geniuses. So if we were to do this one, hey, Canal, where's my asymptote? Try again. Where am I going? -1. It's okay, I'm sorry, Canal, I don't mean to put the pressure on you. But you got it now. Okay, so going back to this, what am I doing to my x's? Oh, times me like, ooh. Factor of 1/3. So take my x's. So x's by 1/3, and then subtract. Oh, this is ugly. Subtract 1. What do I do to my y's? Multiply by what? -2. Sure, we can.
So I remember that he got 9, like where's 9?
Mhm.
I remember that's supposed to be like that, but I don't remember how to get it.
Okay, so we put this into exponential form.
Yeah.
So it's got to be equal to something. So I'm going to say it's equal to y.
Yeah.
So base 3 exponent y equals the argument of x. So when my y value is 2, it gives me 9. Okay, let's do the y's because they're really easy. +4, +2, 0, -2, -4. Because all I was doing to the y's was I was times them by -2. My x's are going to be a little bit ickier. That's a technical term, ickier. So we get times the x's by 1/3, so that's going to be 127. And then I'm going to subtract 1. Times this by a third, we're gonna get 1/9. Subtract from 1, that's gonna be negative 8/9. 1 times by a third is a third. Third minus 1 is gonna be negative 2/3. 3 times by a third, thank goodness we're getting into real numbers now, is 1. 1 minus 1 is 0. 9 times by a third is 3. 3 subtract 1 is 2. Are we good? Can all vote for count? So if you put this into your calculator, you're going to get a really, really, really small decimal, right? So that means you're really, really, really close to your outcome. Hey, do I need to do coordinate pairs if I've done a table of values? Do I need to make sure my increments are on there? No, maybe. I don't know. Seems like a good idea. Don't be afraid of using fractions. What? You terrified of fractions? I want to move on to page 4 just for a second. I know if we can go back and do some extra practice, that's great. I think you got the next week. You're going to practice this on your homework. So I don't want to keep going over. I'm hoping you're going to jump in.
Yes.
A girl can dream. All right. So we have to write an equation for the graph that's transformed from log base 4x. So which one is log base 4x? I think it's labeled. It's the blue, right? Like the blue graph is log base 4x. You know that because at 4, you're at 1. Right? Obviously, duh. Okay, so what you need to know is these dots are transformed because it's kind of hard to see. So this point transforms to that point. So 4, 1 on my original graph transforms to one more. Transforms to 1. There you go. Yeah? And your whole map now would go for here. It's an arrow. It's been seeing something else. All right. So, looking at this, what is something we could do mathematically speaking that would transform this graph? What's changed? Did the y's change? No. So, what am I going to be working with? Something on the x's. Okay, so what do I have to do from 4 to get it to 1? Times my factor of 1/4. How come I can't minus 3? Because that would put me at 1, 2. Because my asymptote moved. So I know it's not a shift because we can see from this, it's got asymptotic behavior at x equals 0. So I know it's not a shift because my asymptote hasn't moved. If my asymptote moves, I know I'm dealing with a shift, but my asymptote didn't move, so it has to be a horizontal stretch. So we're taking our x's. I'm going away. We're multiplying them by 1/4. So what would we write as our transformation? It would be y equals log base 4 4x. Does that make sense, everybody? So anytime you're doing a transformation graph, you're going to look at the point that actually transformed. Okay, so looking at the next one, was there any shifts? Were there any shifts? Did my asymptote move? No. My asymptote, they still have asymptotic behavior at x equals 0. But something's happened. There's a reflection where? So I was at 4, 1, and I transformed to 4, -3. Something else happened. Did I shift 2 units down? Or was it a multiply? Shift? How come a shift? Yeah. Totally, you're fine with that. Sure. Okay, so let's start with this point right here. Let's start with that point right there. That point is shared. It's an invariant point, it's shared by both. So that one is 1 and 0. So if we had done a shift, what would we notice about this invariant point? It would be a shift because it didn't move. The invariant point, that means it's going to be a multiple. The way we learn. So y equals -3 log base 4 x. Because we didn't do anything to the x's. There was a reflection in the x-axis, but mathematically speaking, we multiply the y's by negative. Could you guys have done that on your own?
Yeah.
Well, I think I would have struggled with it too, especially if I got it on an exam where I'm looking at it and sitting there for an hour and a half. What is this? I know there's a reflection, got that. I know it moves 3. So I could see us making a mistake when we're 3 hours into an exam or 2 hours into an exam. So those are some things you're going to have to slow down and look at. Okay. There we go. Welder helmets. I think we should all get welder helmets. I think our days would be much better. So there's the equation. N is the shade number. Okay. Shade numbers range from 2 to 14, with a lens shade number 14 allowing the least amount of light to pass through. If the shade number 12 is suggested for arc welding, what fraction of light passes through the filter to the welder? And it says to the nearest 10,000. What place value is that? Tens, hundreds, thousands, 10,000. So that's as good as we're going to get. So where does the 12 go in this? Does it go in for T or does it go in for N? T or N? Where does 12 go? Where does the number 12 go? It wants to know if 12 is, does it go in for variable N or does it go in for variable T? N. N. Hey, what's the base on the log? It is 10. Nope, base 10. That's the argument. You want to argue? This is the argument. Okay, so order of operations tells me to do what first because we're going in reverse. Okay. -1. So I'm going to subtract 1 from both sides. So I'm going to have then multiply by 3. And then what, Canal? Yes. I give up. Once I did this, was everybody okay with that? So what we're gonna do in that negative front there? What we're gonna do in that negative front? Divide it away, divide it away. So I'm gonna have negative 33 over 7 equals log t. How would I solve that? Ooh, it's a good plan, but I've already got a log. So I can't log a log. No, never divide out logs, you crazy kid. No, you're not dividing anything. You're changing it to exponential form. So what would that be, Kevin? So base 10, because it didn't have one saved, so we know it's base 10. 10 to the exponent negative 33 over 7 equals the argument t. So if you do that, you can then calculator. And it wants it as a percent. So if you did that in your independent calculator, you're going to get 0.0000193 equals t. It wants it as a percent. So what do? Multiply it by 100. Sorry, did I go incorrect? So this would be 0.00193 equals t. What's my problem? Ooh, percent, gonna keep my units in there. What's my problem with that answer? I left the 3 in there, which I shouldn't have, because I need 4 decimal places. So the fraction of light that gets through is 0.0019% of visible light. Barely any light. Yes. Okay.